Very pleased to introduce Eduardo Lagos. He is the on-farm research manager and outreach specialist at the University of Minnesota, and he's currently working on manure management and water quality research. So welcome.
Thank you so much, Bruce. I appreciate the opportunity. Well, good morning, everyone. It's definitely a great pleasure for me to be able to be here with you. It's kind of like interesting as well, and kind of like really huge shoes to fill in this case. I guess we're kind of like covering for Dr. Melissa Wilson. She always has the best pun intended jokes whenever we're going to talk about manure, especially when we're about to get towards lunch. She really would say and start by saying something like, okay, we get to talk about a lot of crap before we go to lunch. So I'm going to go and try and channel that in Melissa today. And tell us a little bit more and share with you about the really cool research that we are doing within our manure management team. Today I will be sharing with you an update about fall manure and the pre-citrus nitrogen test to predict in-season fertilizer needs. So a couple of the two topics that I'm going to cover with you today, kind of like first, just doing a general cover and overview about our recent research experiment. And as well, we'll tell you and share with you a little bit more about the on-farm research program that I'm managing as well, where I see that we have a very decent, huge crowd today as well. So I'm hoping, really hopeful here to potentially make some connections as well for our on-farm research program that is focused on improving manure best management practices across the state. So the pre-citrus nitrogen test, just to provide a little bit of context here, we know that this is a great tool that has been, at least for the last couple of decades. When I say this is a great tool, again, kind of like a series refresher is something, a soil nitrogen test that allows us throughout the growing season to actually tell us if we need to actually supply a little bit more nitrogen to the active crop that we're growing, in this case corn, or if we're actually at a state where we are nitrogen deficient. For sure, this is a great tool, but despite of the fact that it has been used throughout the last couple of decades, this tool has actually been neglected within the manure management realm. And that is why we're trying to propose this as a potential tool to actually be able to predict that potential citrus nitrogen rates that we want to apply within that corn crop. For sure, we know that different things have changed throughout time, throughout modern agriculture, as you can imagine. For sure, we have different hybrids in corn, as all of our past speakers have also mentioned as well about the spatially variable weather conditions that we have within our state. We know that we have spatially variable conditions. So for sure, we need to adapt those as well, and we need to provide more tools in the toolkit of our farmers as well so that they can definitely take corrective actions, apply additional nitrogen if needed, and reach that optimal yield potential that the crop is aiming to have. So the objectives of this study at a high level overall, first of all, we're trying to evaluate the pre-citrus nitrate test for fall applied and liquid dairy and swine manures in order to, again, to predict the citrus nitrogen needs for corn. Second of all, as well, we're trying to compare these pre-citrus nitrate test results within two specific systems. One that is a system that only uses fertilizer applied nitrogen, and the other one that is a combination of the manure base plus additional nitrogen applied within that system. So a little bit of the experimental design. This study was actually conducted throughout 3 years. This study was conducted at the Southern Research and Outreach Center in Waseca, Minnesota. We had two specific cropping rotations. We were using, first of all, a continuous corn and also a corn-soybean rotation. So as you can see in the graph here, that's actually showing the main. Let me activate the pen. Sorry for that. Hopefully you're good. Just a second here. Laser pointer, right there we go. Yeah, found it. So the main crops that we're seeing here, again, kind of like two main blocks of the continuous corn and corn-soybean rotation. We had 3 different treatments, kind of like 2 focus on the fall manure applied treatments, again, kind of like using liquid dairy and also swine manure. And we're comparing this again versus a spring urea applied fertilizer treatment. Kind of like something very important is that the fall applied manure treatments were applied at 120 plant available nitrogen per acre rate. And then again, the fertilizer rate as well was also applied at this baseline rate. Then on the other hand, on top of this, that is where we applied the sidrase urea, and we applied that with a urease inhibitor at different nitrogen rates. For continuous corn, this ranges from 0 to 120 pounds of nitrogen per acre, and for corn soybean, this ranges from 0 to 60 pounds of nitrogen per acre. So sharing in a little bit more of the timeline so that you get a better idea of this study. This again was a 3-year study that started back in 2022. So the timing of the fall manure applied treatments usually were towards the end of October, towards the beginning of November. The actual spring fertilizer that was applied towards the end of April, towards the beginning of May, depending on the cropping year that we had. And again, kind of like this was repeated towards 3 years throughout this specific study. And right now we are at that really exciting moment whenever we actually get to compile all the data that we have collected throughout the years. We get to synthesize that, analyze that as well, and potentially translate that into end users tools that we can share with you all. Again, this is going to be some preliminary data just because, again, we're at that point that we have just finished the last cropping year of this experiment, but we definitely have some interesting updates to share with you by this point. So just to set the tone here, the way that I will explain the results, the preliminary results of this study, is that I will always start by setting the tone, by sharing the specific precipitation of that growing season. After that, we will look into the specific PSNT results, the inorganic nitrogen that was in the soil, and then we will look into how that reflected into the yield. So first of all, for the first season, we were able to see kind of like setting up the graph here. You can see in the black bolded line, that's actually the cumulative precipitation. And the different shades of blue actually show the deviation from the 3-year normal. So above average or under average. As you can see, for this specific first season of the experiment, we had relatively normal conditions as we started as we began the season. However, after we actually got to apply the spring fertilization, we actually received above normal precipitations. In this case, it was around 6 inches of rain throughout the entire month of May. And that in reality, as you might be able to tell, that's a lot of rain to receive within one single month. So that definitely had an impact within our system. As you can imagine, all of these influences the different mineralization rates that we have within our system. And this is manure we're talking about, right? So that's definitely going to have an impact as well on the potential outcome we have in our crop yield potential. So to transition a little bit here, first of all, starting with the PSNT, meaning the amount of nitrogen that is available in the soil. Let me set up this graph a little bit for you here. So as you can see on the y-axis, we have the inorganic nitrogen content. This is going to be a stacked bar graph, so meaning that first I'm going to present to you the 0 to 12 depths for nitrate and ammonium, and then we're going to go deeper as well in the soil profile from 12 to 24 inches. Here you can see the different treatments as well that are color-coded as you can see down below. And the blue line that is crossing both of the graphs actually is just a reminder so that we can remember about that specific threshold of the PSNT, that it's around 21 parts per million. Not around, actually at 21 parts per million, pardon. So the idea is that anything that is above that specific line, that means that in theory we have enough nitrogen, we don't need to supply additional nitrogen. If we're below that one, that means that we need to apply more nitrogen into the system. So beginning to digest the first year of the results, we're able to see a couple of interesting interactions. One of the first one being that you can observe that for both of the fall applied manure treatments, we actually had little to no nitrate within the top layer of the soil. Actually, whenever you compare both systems, in both cropping systems, you have the continuous corn and the corn soybean, you're able to see that both scenarios actually end up resulting in similar amounts as our checks or our no nitrogen applied treatments. Then on the other hand, whenever we compare this towards the spring fertilizer application, we're able to see around 10 parts per million for both of the cropping systems. Again, this might be great whenever we compare it to the other treatments, meaning that we have some nitrate in the system. But again, if it's under the blue line, that means that in this specific scenario, we still need to provide or to supply more nitrogen. Now again, as we stack things, as you're seeing here, we have the ammonium as well at the 0 to 12 inch depth. So we see a very similar pattern in reality, kind of like showing similar behavior for the fall applied manure treatments whenever we compare them to our 0 or check rates. But then on the other hand, for the spring fertilizer, we're able to see that it actually did kind of like a decent job, for sure, kind of like going above that threshold. But again, this is a combination of ammonia and nitrate. And again, because we're scientists and sometimes it seems that we want to test our boundaries, we said, okay, let's definitely go deeper and see what happens deeper down in the soil. So as we go deeper down in the soil, things actually get even more interesting because there we're able to see a different pattern. First of all, you're able to see in the yellow bar graphs or the yellow component of those bar graphs, kind of like a lower amount of nitrate specifically for this year. And actually most of the nitrogen that we found at a deeper depth was actually in the ammonium form. Actually, this reveals a couple of more things that we're going to see in the yield in the slide after. So for you to note, first of all, again, that overall throughout the entire 0 to 24 depth, we're able to see that the fall applied manure treatments actually had similar inorganic nitrogen contents for both of the cropping systems. Then on the no nitrogen as well as the spring fertilizer treatments, they actually resulted in about the same amount of inorganic nitrogen for both of the cropping systems. Now, translating this a little bit in how does it reflect in the yield, and here is where things really start to click. So first of all, kind of like setting up the graph so that you can, it's easier to follow. You can see on the y-axis the corn yield in bushels per acre. On the different colored lines, you will be able to see the different treatments for the spring fertilizer, the fall applied manure treatments, and the blue dots in this case actually represent the yield for our check or no nitrogen applied treatment. So also another important caveat for you to note is that on the x-axis, you will note that I have both the side dress nitrogen rate as well as the total nitrogen rate. In this case, you will notice that for the total nitrogen rate, we begin at 120 pounds of nitrogen per acre, just because again, that is the baseline that we applied for all of the treatments that we had in this study. So on top of that, that actually ends up increasing as we move forward in greater amounts of side dress nitrogen, again, from 0 to 120 for continuous corn and from 0 to 60 in the corn soybean system. So a couple of things that we were able to observe in the first year of the experiment, kind of like one of the evident ones that you can see that stands out in the graph, is that definitely the maroon lines in both of the systems, representing in this case the spring fertilizer applied treatments, actually ended up out yielding and out competing both of the fall applied manure treatments. As you can see, again, kind of like going back to the PSNT, we were able to see that greater amount of inorganic nitrogen in the soil, explaining this response within the yields. Then on the other hand, we're also able to see that regardless of the source, meaning in this case dairy or swine manure, we actually had a similar response between both of the systems. Then one of the really interesting ones that at least as a scientist to me, it's always really interesting to see is the fact that sometimes even a small cultural practice within these systems can actually have a great impact within the nitrogen dynamics of these systems. And it's very easy to see because as you are able to note in the blue dots, the comparison between the continuous corn and the corn soybean systems for the specific yield, we're actually able to double that amount of yield just by including that soybean within the rotation. Then on the other hand, whenever we think about the spring fertilizer that we're applying, we really we're not able to see that much of a response for the first year of the experiment. As you're able to see, whenever we factor in that cost of applying extra nitrogen throughout the season, it really didn't pay off, again, going back in and applying additional nitrogen. There was some sort of a response for continuous corn, but definitely it's minimal. And for corn after soybean, definitely that response was not there. So again, going back to the second year or moving forward to the second year of the experiment, first setting the tone with the specific precipitation patterns that we had for that year, kind of like a very similar condition and context as the one that we had on the first year of the experiment. Here, kind of like the main difference is that we had kind of like a relatively normal pattern towards the beginning of the season, but then again, similar to the first year of the experiment, we're able to see that by the time that June hit, we already had around 7 inches more of precipitation compared to a 30-year average. Kind of like one of the main differences that I think that it's interesting in this precipitation pattern of this year is that that particular wetter spring and early summer actually was sustained throughout the entire portion of the specific growing year. And now we will going to be able to see how that actually affected and impacted the second year of the study. So again, same setup, you're able to see on the blue line, kind of like that threshold for the PSNT. We have the treatment comparisons, again, starting with the 0 to 12 depth and specifically doing the nitrate component. So in here, we actually were able to see a greater concentration across the treatments of nitrate. We're able to see that for the fall applied manure, we actually had a greater concentration compared to the first year of the experiment. However, whenever we put that in relation towards the no nitrogen applied treatments, we're actually able to see that we have similar amounts of nitrate. Whenever we compare this towards the spring fertilizer treatments that we had, we're also able to see that we have greater nitrate in the system, above 10 parts per million. But again, it's all a matter of perspective, right? It's still a greater amount of nitrate, but it's still under that specific threshold for the PSNT, meaning that again, we need to apply additional nitrogen. Whenever we stack the ammonium component, we're able to see as well a similar pattern as the one that we saw with nitrate. Kind of like things don't change that much. Kind of like one of the interesting things, or outstanding things at least, is that for the continuous corn system, we're actually able to see kind of like a greater concentration in organic nitrogen, the 0 to 12 depth for the swine manure. Compared to the other dairy manure treatment in this system. And then on the other hand, in the cropping system, the corn, soybean, we're actually able to see similar results. And again, whenever we put things in perspective, comparing the no nitrogen and the spring fertilizer applied treatment, we're able to see similar contents in inorganic nitrogen throughout the soil profile, or at least in the 0 to 12 depth. Now, things get really interesting whenever we go deeper in the soil. Here, as you can see, visually, it really stands out. Kind of like that yellow stack bar graph is actually showing, again, the nitrate component within that 12 to 24 depth. So this is very curious because like we're able to see, and going back as we associate this towards the precipitation patterns that we saw in this specific year, we know that we had an actual earlier growing season that was wetter, meaning that there potentially was more mineralization, and as well at the same time that nitrate potentially moved or percolated further down the soil profile. That's why most of that nitrate was actually deeper in the soil profile at the 12 to 24 depth. We're able to see as well from that gray component that we didn't have that much of the ammonium component, specifically as we went down in the soil profile. Now, how all of this relates towards the yield, and here's where things really start to make a lot of sense. So again, for the continuous corn, we're able to see a similar pattern as the previous year, kind of like seeing that the maroon line, in this case, the spring fertilization treatment, ended up outcompeting again the fall applied manure treatments. Then on the other hand, for the corn after soybean, this difference was actually more narrower, and that actually is tied towards what we were seeing in the PSNT that I presented before. Then on the other hand, whenever we compare both of the fall applied manure treatments, we see that there are not that many differences. We see kind of like some improvements for the swine manure that, as I go back, it's all tied towards the PSNT that we saw in the previous slide. Then on the other hand as well, we see whenever we reference the yield that we got from the no nitrogen treatments in this case, we're able to see that both of the systems actually ended up yielding about the same. So the blue dots that you can see in here. And a lot of that actually explains and reveals a lot about the mineralization patterns that we potentially had throughout this season. Remember, again, we had, yes, it's true, weather kind of like conditions towards the beginning, but these conditions were sustained towards the entire season, potentially allowing for a greater mineralization in the continuous corn system, and potentially as well allowing for it to match up with the corn after soybean rotation yield. Now for the 2025 last season, unfortunately, this is going to come in with a caveat, and is that again, because we're wrapping up the analysis of these data, as of now, we just count with the specific yield data. We don't have the PSNT, so we're only going to be able to see part of the story in this case, but it's still interesting enough that it tells us a lot of patterns that we saw in previous years that actually help us really nail down into the actual conclusions that we want to get out of this study. Again, just setting the tone in the precipitation patterns that we saw here, it was actually really fortunate in this case because, again, whenever we do a longer term experiment, 3+ years, we usually want to capture this variability, different weather conditions that actually allow us to quantify the effect of our treatments or to see how those treatments react according to that specific variability. So again, kind of like more of a normal precipitation, especially throughout more of the season. As we can see later in the season, we start getting more of that precipitation and deviation from the 30-year average. But again, around the time that we applied the fertilizer, we had relatively normal conditions. Now, towards the third year of the experiment, yes, it's true, we only are seeing part of the story here. We don't have that PSNT yet, but we're seeing some validations, at least on the patterns that we're seeing from previous years. One of those being in continuous corn, as you can see again, it consistently ends up outperforming the spring fertilizer treatment in relation to the fall applied manure treatments. Here as well, it's very interesting to see kind of like more of a difference between the manure sources, both the swine and the dairy for the continuous corn system. And we're also able to see more of that response from the side dress additional nitrogen applied in this system. Then on the other hand, for the corn after soybean treatment, we are able to see something similar as the previous year, where we have more of a narrow difference. And actually the differences again between the spring fertilizer treatment and the fall manure applied treatments is actually not that broad, or they actually end up being relatively the same. So a couple of things that we have learned so far. Yes, it's true. Again, this is preliminary data, but this is already telling us a lot of really good conclusions. And probably as we dig deeper into the data, we're going to be able to solidify the quantification of these conclusions. First of all, one of the big ones, though, that we can go ahead and share with you is that, as we know, manure can definitely be very variable, especially whenever we apply it during the fall. We know, again, and we're conscious that we're working with liquid manure in this case. So we know that it's going to have a greater ammonium concentration whenever we compare that to a solid manure source. So we know that definitely this is going to be very impacted by the actual precipitation, weather conditions that we have throughout the season. And this as well will affect the final outcome that we have on our specific yields and our ability to use this tool. On the other hand, however, we were able to see that the PSNT definitely showed differences between the nutrient sources. So really great news, because we think that fine-tuning this tool can actually allow us to further fine-tune the amount of side dress nitrogen that we apply for our corn crop, especially whenever we have manured fields out there. And finally, we're also conscious that this is, again, really exciting, cool data and research, but we're also cognizant of the fact that this is 3 years of data in a pilot study that was done in one specific location. So for sure, we need to replicate more this study, different regions of Minnesota. We know that our state is very spatially diverse as well. And we know that we have different weather conditions across the state. So we definitely need to test these out across different regions so that we can further fine-tune the tool as well whenever we want to provide it to our end users. This could actually lead, again, this is on the small plot type of setup, but this could actually lead even to an on-farm application as well, so that we can further validate the tool. And that's actually a great segue towards the program that I'm leading in right now. This is kind of like a mini marketing strategy as well that we wanted to take advantage of the space and share with you all, and tell you a little bit more about our on-farm research program. So as of now, we're still in the lookout for cooperators and collaborators to join us in our on-farm research. Kind of like at a high level, this program is really focused on improving the manure best management practices across the state of Minnesota. I think that that's one of the really beautiful things of this experiment and this program overall, is that because it has a really broad mandate, it really allows us to test different potential innovations, research questions with farmers out there across the state. The idea is to have 12 experiments across 2 years. As of now, for this specific growing season, the first 6 experiments, we have 4 of those lots already filled out. So for sure, if you know about potential contacts, people out there in the southern region of the state that might be interested in conducting on-farm research, definitely let us know. I'm going to hang around as well after this, so definitely let's connect and talk a little bit more about those folks. Then on the other hand as well, this is a program that it also really tries to force or tries to push a lot of the co-designing process of an experiment with the farmer. We know that they're the actual applied scientists out there. They get a bunch of research questions. They are the ones actually trying to apply these end user tools. So actually throughout this process, it has been something very fulfilling, kind of like doing that co-design process with the farmers in order to actually tackle the research questions. A couple of examples that I can share with you of some of the things that we're exploring right now. This includes everything from doing cover crop interactions with manure application, as well as actually just testing a novel technology from John Deere that actually allows us to measure the nutrient content from manure on real time. Some other examples that we're interested in testing out, that includes things as testing nitrification inhibitors, as well as even doing the PSNT study that I just explained at the on-farm level. That would be something really neat to have. And more importantly as well, is that, kind of like what we're trying to do with this program is not overcomplicate, overburden the farmer, but actually we want to integrate and, actually make this as real as possible. Something that is easy to apply, but that at the same time actually gives us very robust, sound scientific science answers to the hypothesis that we try to propose. So with that being said, I don't want to end up this presentation without, again, remembering about all of our funders that actually make us and allow us or give us the possibility to pursue this incredible research. For sure, a huge shout out as well. That I know we have a bunch of members in the room from Africa. Also, a huge shout out to them as always. Same as the Minnesota Department of Agriculture for allowing us to fund this work. And more importantly, as well as always, a huge shout out to the people that the magic behind the scenes, the people that actually allow us to pursue this great research. So to Jeff and Kyle from the SROC team, as well as the entire Wilson Lab staff. With that being said, here's my contact information. But again, I'm going to be around, so more than happy to connect with you, talk more about manure management research. Again, as Melissa likes to say, kind of like trying to transform the poop into the sweet stuff. We're really excited about that. So definitely make sure to connect with me and even to potentially talk about on-farm partnerships. So with that being said, I would love to entertain any questions from the audience. And I see that we have a couple here. So the first question says, are you advocating that we should measure ammonium as part of a pre-citrus soil test? I would say that not necessarily advocating. I think that the reason that why that component was included within this experiment is because we're talking about manure. So we know that that's also going to be an important component into the equation. I think that depending on kind of like the system that we have, what we're trying to address, maybe that answer might change. But again, just kind of like relating it to the actual experiment that we had. That's one of the reasons why we really also wanted to understand kind of like that ammonium component, kind of like getting the whole picture. Because again, we know we're talking about manure. We know that manure is a gift that keeps giving, as we always say. So that's definitely another important component to evaluate. It says that this study was at Waseca with loam soils. Is that PSNT a useful tool on sandy soils in central Minnesota? I think that on that end, I would say that it's probably applicable as well. I know that other considerations might need to be definitely factored in. We're talking about sandy soils prone to nitrate losses. So I think that the game entirely changes for sandy soils specifically. Definitely something that could be tested out because again, we're scientists, so why not test it out? But I think that definitely would factor into the equation there, just the whole different game that sandy soils actually imply. And then the final question, in the second and third years of the study at the same location where first and second year manure nitrogen credits counted for the total nitrogen applied. Actually, no, they were not accounted. And one of the reasons is because I probably forgot to mention this on the materials and methods. This study was 3 years in the same research center, but it was actually 3 separate sites. So actually, whenever we designed the experiment, we only factored in the first year plant available nitrogen in order to calibrate those specific rates and the manure that we applied. So any questions from, yeah.
The questions? Yes, sir.
How was the manure applied?
Yeah,
With covering disc or narrow knives?
yeah, it was knifed. Yes, the manure was knifed. And yeah, that's the procedure that we had. And again, the urea, kind of like using that urea plus the urease inhibitor on the spring.
Good questions. Yeah, Eduardo. All right, let's give him a hand. Thank you.
Thank you so much.